Sorry, I got cut off there one more time. And we'll go with this here. So we talked about x has to be less than 33 because the 2x plus 9 has to be less than 75. And so now I'm going to go think about, all right, it has to be less than 33. Does 2x plus 9 have to be greater than anything? And just like before we talked about with the side length, an angle right here, the smallest an angle could possibly be is 0. So we do know that 2x plus 9 has to be greater than 0. So I'll solve that too. So that means that 2x is greater than negative 9. And that also means that divided by 2, x has to be greater than negative 4.5. So if we look at our relationship here, the range of values then would be x has to be greater than 4.5, but it has to be less than 33. First one is related to the Hinge theorem. So we got that relationship where it has to be less than that 75, but also logically 2x plus 9 is an angle, and all angles have to be greater than 0. So there is our range that we have. Last problem on the practice. We can check our answers here. All right, so I'm going to outline our hinge again. We'll notice we've got 5x here and 5x here. We've got the shared side, so our first hinge is the 60 degrees, and our second hinge up here is going to be this hinge here. Okay, so we've got a little tricky part here. Notice that we have an angle here that's marked as 90 degrees. We have 60, so that's 30. 30 plus 60 is 90, which leaves us 180 minus 95 minus 30 is 55. So this angle up here is 55 degrees. So a little tricky there, but we actually have to get that because the hinge is at the 55. The hinge is not the 30. The hinge is not the 95. Again, the reason I know that is based on what's the included angle between the two congruent parts here. It's this angle, and then 60 is the angle between the two congruent parts down here. All right, so let's relate our pieces together. So 60 is related to the 5x plus 3 as the opposite side, and the 55 is related to the 3x plus 17 piece over here. All right, so we know the angles, and so now we should be able to relate the sides together. This time we've got a couple of expressions that we have. So we'll notice that the 5x plus 3 is across from the bigger angle than the 3x plus 17. So therefore, 5x plus 3 is greater than 3x plus 17. So now we got to do a little bit more work on solving this one. Let's get our variables on the same side of the equation. Same side of the inequality, I should say. And so that leaves us with 2x plus 3 is greater than 17. And then we've got subtract 3, and that leaves us with 2x is greater than 14. Dividing by 2, get x is greater than 7. So that's the first piece, x is greater than 7. So now let's think about, is there anything else that we need to worry about here? So we do know is that our 5x plus 3 and our 3x plus 17, for that matter, have to be greater than 0. So let's take a look here. Because the side length has to be greater than 7, and then it also has to be greater than 0. Okay, well, we already know that it has to be greater than 7. So maybe that's all we need in this case, because now let's think about the reverse of that. We know it has to be greater than 7. So of course it's going to be greater than 0 if it's greater than 7. Does it have to be less than something? Does 5x plus 3 have to be less than something? Is there an upper bound to what that side length would have to be? In this case, I don't think so. We already figured out the hinge piece. And so it's not like it's an angle where it has to be less than 180 degrees. We already said it's greater than 0, and we already said it's greater than 7, actually. So I think this is our final answer for this one, that we don't really have a range of values. We just have to say that x has to be greater than 7. And if x is greater than 7, then I think we're good with how the rest apply.